Three AI agents were building a project together. One of them made a decision, and 20 turns later, another agent asked what it was. The entire conversation was right there in front of it, and it still couldn't answer. But a tiny graph got it right, using 18 times fewer words. How? Here's the obvious fix. Just keep everything, every message, every decision, appended to one long transcript and handed back to the model on every single question. The planner picks postgres, and then that decision gets buried under 20 turns of "sounds good" and "I'll get to it." It works, technically, but the transcript grows forever, and every new question rereads the entire pile. Your token bill climbs with every turn, even when nothing important was said. So you switch to vector search. Instead of resending everything, you store each turn as a chunk and pull back only the few that look similar to the question. For a single fact, this works beautifully. What storage did we pick? Finds the right chunk. But now ask something harder. What does the storage module depend on? The decision lives in one chunk. The dependency lives in another. Vector search can find both, but it has no way to draw the line between them. Similar isn't the same as connected. And this is the real problem. It was never about noise or token cost. It's about structure. Some questions can only be answered by combining two separate facts. Which component does the module owned by the implementer depend on? There is no single turn that holds that answer. It's stated in pieces, turns apart. The answer isn't a chunk sitting somewhere. It's a path between facts. So change what you store. Instead of text, store entities and the relationships between them. The implementer is assigned to the auth module. The auth module depends on the rate limiter. Now that hard question becomes a walk. Start at the implementer, follow, assigned to the module, follow, depends on, to the answer. 2 facts, 1 traversal. But building this honestly surfaced a real bug. A support ticket starts at priority high, then gets bumped to critical. The graph kept both and answered high. Stale, but with total confidence. That's worse than a fuzzy guess, because it looks authoritative. The fix: when a fact is restated, drop the old link, walk the links, and drop the stale ones. So does it actually work? 5 scenarios, 18 queries, fully deterministic, 0 LLM calls, reproduced identically on 2 separate machines. On overall accuracy, the context graph, 89%. The raw dump, 61. Vector search, 50. But the real story is the join questions, the ones that need 2 facts combined. The graph gets 80%. The others, 20 to 40. That gap is the whole argument. And it does it using 18 times fewer tokens than the raw dump. Not a trade-off, a win on both axes. No bigger model, no longer context, just a different way of representing what the system already knew. None of this required more memory, just a better shape for it, which leaves a quieter question. How much of what we call memory is really just knowing what connects to what?